All right, right here, what we're going to do now is talk about proving triangles similar. So we're going to determine if the following triangles can be proved similar. If so, state the theorem or postulate used, and then write a similarity statement. All right, so remember our choices are angle, 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 side, or excuse me, almost brain farted, side, angle, side, and side, side, side. Those are our three choices. So if two angles in a triangle are congruent, the triangles must be similar. Using that fact, well, look at this one right here. Let's actually be incredibly tedious because this is going to actually help us in the future. Looking at this one right here, notice that triangle. Let's call this DBC. Well, that's a right angle. Well, looking at this one right here, you have this bigger one. Triangle ADC. Well, that's a right angle. And notice how these two triangles share angle C. So angle C is congruent to itself. So they both have a right angle. They both have angle C. So are these two triangles similar? We're going to write yes. Now furthermore, watch this. This is going to blow your mind. There's actually a third triangle that's been chilling there all along. It's this medium-sized triangle. Notice that triangle ABD also has a right angle. Now watch this. So all three have a right angle. Then this green triangle has angle A. This orange triangle has angle A. So boom, they're congruent to each other because they both have a right angle and angle A, which is congruent to itself. And then lastly, this green triangle and this pink triangle both have angle D. Actually, no. Well, they do have an angle D, but they're different. The way I want to explain it actually changed my mind. Is let's do it like this. We're going to write yes. So both these triangles are congruent to the orange triangle by angle, angle. Now we can write this. We can write triangle ADC is similar to triangle DBC. And we can write triangle ADC similar to triangle ABD. Alright, so those two triangles are congruent by angle, angle. And then for fun, we can say that this last one we actually have triangle ABD is similar to triangle DBC by transitive. Alright, since they're similar to the same triangle, they must be similar to each other. All right, something this complicated, I don't think we'll see on the test, but it's fun to talk about in great detail, make us really good at the stuff we're talking about. This next one right here, are these triangles similar? Well, let's just quickly match up all the corresponding sides. 12 over 18, 2/3, 10 over 15, 2/3, and then 8 over 12, 2/3. So realize all the corresponding sides are proportional. Matched them up, simplified them, it's all 2/3. When that's the case, yes, they are similar. The answer is yes, by side, side, side. And then the similarity statement will be triangle ABC is similar to triangle DEF. All right, and remember when you do this on your own, there's a bunch of them. Like I could say, well, triangle BAC. Well, then I just have to match up the corresponding sides or corresponding angles. There's a plenty more. I think there's 6 total, so there's 4 other similarity statements I could write. Those are just 2 examples of what I could. All right. This next one right here. Again, another way to think about it as well. 12, how do I get 12 to 36? Multiply by 3. How do I get from 15 to 45? Multiply by 3. So these sides are proportional. And notice how the sides that are proportional, notice how there's an included angle. And this included angle is congruent. So when we have two sides that are proportional and the included angle congruent, we can say side angle side. And similarity statement, there's none to write right here. We'll just write question mark because there's no letters. Or we can just really fast say, let's call this triangle and RU. We could say triangle AND is similar to triangle REW. And then this last one right here, well, a couple ways to think about this. Just automatically know we have vertical angles. Furthermore, parallel lines, huge punchline of geometry. See this as a transversal. Remember, these are alternate. Interior angles. So in this particular case, I can say yes, again, just using angle, angle. And I can say triangle ABE is similar to triangle DBC. All right, so that's just some similarity stuff right there. That's how you prove them to be similar. Pretty cool stuff right there. Again, and let's just dive into some more triangle proportionality stuff. Again, it just seems like no matter what we do, it seems like we're setting up proportions and cross multiplying. But looking at this stuff right here, remember this is like that triangle proportionality theorem that we were just talking about, that I forgot the name. That's the triangle proportionality theorem. If I extend these parallel lines, well look, that's a triangle, and then we have a different triangle, so on and so forth. Really just match up stuff. Match up corresponding parts, be super careful. So in this, I'm going to say 3x over 5x equals 60 over 8x. All right, this problem's not meant to scare you, but we have 3x over 5x, and I typically don't simplify first. I usually just start bashing computations and see what happens. Well, let's clean this up first, because we have x over x. Those are gone, disappeared. They kill each other. They're never coming back. Say goodbye. All right, then once we cross multiply, now things are going to be much cleaner. We're going to get 24x equals 300. Divide both sides by 24. What's 300 divided by 24? Does anyone know? 12.5. All right. I'm just looking at some stuff. We're going to see that we have the same, so 0.6. So realize when you plug this in here, what I was just doing in my calculator for fun is we got 37.5, 62.5. That's a relationship of 0.6. Plugging in here, 100, relationship of 0.6. Just emphasizing, I was just plugging it back in, emphasizing that in fact breaks it up proportionally. And this one right here, we got to find x and y. All right, so I'm a little confused. What should I do? I don't really know. Looking right here, I don't think I can find x first, or can I? Well, look at this. Let's just focus on this small part right here. We can say, well, that's clearly 30 over 14. All right, so this problem's good because it's forcing us to think a little bit and match up corresponding parts. This over here, well, what's this left side? It's 30 plus x. So then I can say, well, now I'm going to have 30 plus x over 22. Set them equal to each other, put parentheses, and again, just a massive amounts of cross multiplying. All right, and then it becomes a lot of repetition with distributing, so on and so forth. Again, hopefully you've been trying to do most of this review on your own. That way You can then check your work, see what you're good at, see what you're not good at, so on and so forth. So we're going to get some crazy decimal, 17.1-ish. All right, 17.1-ish. And then we're going to do a similar thing for y. All right, so now what we're going to do is actually just the same exact thing, but just looking at the opposite side, so y to 14. So I can say, well, I got y to 14, and then I got, well, what's that side right there? Y plus 15 is that whole thing. So then I can say y plus 15 over 22. So again, incredibly similar problem, a lot of the same thinking going on. You should be really good at setting up proportions, cross multiplying, carefully solving by the end of this review guide, if you weren't already, which I bet you guys were, because you guys are some pretty smart people, mainly because you got a really good math teacher, but nonetheless. In this case right here, y is going to equal 26.25. All right, long review, 1 page left, we're almost done.